I'm Sarah, and today we're going to be doing some stoichiometry problems with quantities that we measure in molarities. So we're reacting 3 milliliters of 10 molar hydrochloric acid with zinc. We're going to produce zinc chloride and hydrogen gas. If we want to consume all of the hydrochloric acid in our reaction, how many grams of zinc should we add? So first of all, let's figure out what our quantity is. So we have 3.0 milliliters of 10 molar hydrochloric acid. That's our first quantity. We want to end up with grams of zinc. So we're going to need to convert between the two. Let's figure out what our stoichiometric ratio is because we're converting between one reagent to another reagent. We can see right here that for every 2 moles of hydrochloric acid, we have 1 mole of zinc reacting. So that will be our stoichiometric ratio. 1 zinc per 2 hydrochloric acid. And this could be in moles or molecules. We're going to use moles because we're working with molarity. So there's our stoichiometric ratio, and that's a conversion factor that lets us switch between hydrochloric acid and zinc when we're trying to figure out what quantities of the two we should react. So let's set up our equation. We have 3 milliliters of hydrochloric acid. Well, we have molarity in moles per liter, as you know, so we're going to need to convert that to liters. So we're going to take 1 liter over 1,000 milliliters to cancel out milliliters. Then we've got our molarity, which is 10 moles hydrochloric acid per liter, so we can cancel out liters. Now that we're in moles, that's where our stoichiometric ratio comes in, because it converts us between moles of one quantity to moles of the other. This is already set up with moles of hydrochloric acid on the bottom, so we can just plug that in, and we can cross out moles HCl. Now that we're in moles of zinc, we're going to need to convert that to grams, because if you remember, we wanted to end up in grams. So the last thing we need for that is the molar mass of zinc up here, which is grams per mole. So we can just plug that into 65.38 grams zinc per mole of zinc. Cross out moles, and if you go back through, you'll see we've canceled everything out, so the only thing we have left is grams zinc, and that's exactly what we want. And if we go back through and do all that math, we get 0.9807 grams of zinc, which, since we only have 2 sig figs, is 0.98 grams of zinc. That's how many grams of zinc we're going to need to react with our hydrochloric acid. So in our next step, let's figure out what is the molarity of the zinc chloride that we're going to make. We're working with 3 milliliters of hydrochloric acid, so that's going to be our final volume. So let's take the information we have to the next page. We're starting out with 3.0 milliliters of HCl and 0.98 grams of zinc. We want to end up with zinc chloride molarity in a 3.0 milliliter solution. So there's actually 2 different ways we could do this. Now that we have quantities for both of our reagents, we could use the stoichiometric ratio between zinc and zinc chloride, or between hydrochloric acid and zinc chloride. So in this case, we're going to go with hydrochloric acid and zinc chloride. That's the same ratio as we had before between hydrochloric acid and zinc. We have 2 moles of HCl per 1 mole of zinc chloride. We're working now with a product and a reagent, but the conversion factor works exactly the same way because they're all part of the same reaction. So now we can set this up. We're going to start with our quantity of hydrochloric acid because hydrochloric acid is what we chose to use for stoichiometric ratio, and we're going to end up with molarity. So 3.0 milliliters of HCl, let's convert that into liters, and let's convert that into moles by taking our molarity, 10 moles per liter. Now we have the conversion factor. This time I've written it upside down. I wrote 2 moles hydrochloric acid per 1 mole zinc chloride, but that's the same as saying 1 mole zinc chloride per 2 moles hydrochloric acid. I should add hydrochloric acid right there. Now this time we don't need to find grams, so we have moles right now, moles of zinc chloride, and we want molarity. That means our next step has to be to divide by the volume of the solution we're going to put it in, which in this case is 3 milliliters. So we're just going to take 1, so that would just be our solution, and 3 milliliters, so we can divide by milliliters. Of course, we still have to convert that into liters. Oops. And this time it's going to be 1,000 milliliters per liter. That should give us our molarity. And if you work out all that math, you will get 5.0. That's the molarity of our zinc chloride solution after our reaction.